So we are using Windows 10 machine. Like in a Windows 10 machine, we already disabled Windows Defender, firewall, and antivirus updates, and enable like file extensions and the hidden folders view. And we downloaded the tools required for the malware analysis, static analysis, and dynamic analysis. So what is malware? Malicious software. It can have a malicious behavior. Comparing with a normal software, it like so without user permission, it can may steal some sensitive information or may establish like a remote connection. Someone can remotely can control your PC. Okay. So if someone want to like control your PC, like they have to mention the like IP address, their IP address, or their domain name, port number, and like what type of service they want to run in your computer. So they have to leave their footprints in a part of the source code. So that's why when you do the source code review, you can find some things. Is it has a malicious behavior or not? We can figure out. So when you do the malware analysis, especially static analysis. So we need a tools like so we downloaded like we install like a Wireshark and like we install like a tool name is called like a resource hacker, and we have like a sys internal suite, PE Studio, DI, and CFF Explorer. So we need a malware samples for our practice. Already recommended to download the practical malware analysis labs. Okay, for the practice to understand the possibilities. So let me download the few malware samples for this analysis. So I just like downloaded that file. So practical malware analysis labs. It is going to be extract and like give the files list. I'm extracting in a downloads. Now you can see all the labs. They're binary files, chapter wise. There is a practical malware analysis book. Okay, so in that book, like that author used like some sample. Okay, malicious code for the explanation. That code it is. Okay, so even like you can go through that book also if you want to become master in a malware analysis. Already given that access to you. So we can find that in a Google Drive, shared resources. Malware analysis folder we have. Videos and everything, books and everything we can find. Okay, let me take like so this chapter one like a lab files. Okay, let me download the real malware also. Not this labs, real malware. This is our old institute name. Take details. So those days, See, our team, like, so those guys, like, maintain the blog. This is not inactive right now. Okay, so that time we posted some samples. You can use those samples for your practice. Okay, let's download this zip file. So don't download these files into your main system because all are malicious files. So it required it is a password protected password. So in article mentioned that. Okay. So we have like a lab and we have some real malware behavioral. Okay, we will analyze now. So let me close this. So we have like a original malware files and lab files we have. Now we will do the analysis on them. So what we do in a static analysis, like so we have a static analysis, dynamic analysis process. Part of the static analysis, we have to identify the file type. Is your suspicious file is executable file or non-executable file? PE means portable executable. Is it portable executable file or non-portable executable file? So what is portable executable file? EXE file. It is executable. DLL file, it is executable. Okay, batch file, it is executable. We have a few files, executable format files compatible with the Windows systems. Few files are compatible with the Linux systems. So you need to figure out what are the compatible executable formats we have. So those are like PE files or not, like we need to identify. Sometimes malware can spread through the non-PE files also. It means hacker don't send the direct executable file. He will send the embedded file. It means he will send the PDF file to you. He will send the Word file to you. Those are non-PE files. They are not directly executable. But inside of that file, he can embed the malware. When you open the Word or when you open the like a PDF, it can trigger the code. That makes sense. So you need to identify the file type. After that, you need to observe. If file is sometimes like a hacker, they don't use direct malware. If they send the direct malware to you, your antivirus can detect easily. Your EDR can detect the behavior easily. To avoid the defense detection mechanism. So they want like a bypass the antivirus, bypass the EDR solutions. So it means like they want to like evade the antivirus products, EDR products. For that purpose, they follow the mechanism name is called either packer or dropper or cryptor. So those are like a techniques they use. It means packer, what it will do, it will pack the code. It means it will convert the code packer. Now we have a code. This is your actual malware code. Before that, it has a patched format. So their package is going to be add first. Hide your actual code. Your code is in an encoded format. That code is directly decoded. If it is encrypted, it is decrypted, directly loaded into the memory of the computer. If someone see that packed program, they can't able to figure out the malicious behavior because it is a packed. They are hiding the actual malware code by using packaging mechanism. Guys are able to follow me. If you do the malware analysis on packed program as it is, you miss the chance to find the malware. So first you need to detect that is it a packed or unpacked. Is it a packed or not? If it is a packed, unpack it first. Then investigate. You will find the exact motive goal of the criminal. So thing is that. packer we have. So they can use a cryptor they can use. Cryptor also similar to the packer, but it is focusing more on fully undetectable mechanism. So it will encrypt the file. It will encrypt the file. So hackers try to encrypt the malicious program multiple times in a multiple iterations. Now what happened? It will change the hash value. File hash is going to be changed. File integrity is going to be changed. Am I right? Automatically antivirus fail to detect if it is using signature based approach. That's my point. It is not easy to read. It is not easy to reverse that encrypted code because you should know decryption process. So cryptors they can use. They can use the packers, they can use the cryptors. So they can use the wrappers. So wrappers they can use. Inside of another software installation, they do this. For example, you downloaded a Chrome from the third-party source in internet. You are installing the Chrome, but along with the Chrome, they will install the backdoor also. High level, we can see the Chrome installation, but in the background, so there is a backdoor installation also there. Wrapper, so wrapping inside of this something else. Guys are able to follow me. So we have a downloader. Whatever file you have now, that file is not a malicious. It's not a malicious. If you investigate on that, you can't find any malicious behavior because that file is a downloader. It has only one functionality, download some other file. It don't have a malicious behavior code. It is designed purposefully to download the malware from the other sources after running this. Now you executed a downloader. Downloader don't have any malicious behavior. It has a only simple functionality, downloading file. Now what the downloader is doing? If you scan the downloader, it is a clean. Because it don't have a malicious code inside of that. But what it is doing? It is downloading the malware from some server, running that, persisting that in some other place. So hackers can pack or wrap it our cryptors they can use or a downloader they can use. You need to identify that. Is it an actual program or is it a packed program or wrapped program? So you need to figure out that. So you need to identify that. Okay. Next, you need to calculate the file hash. You need to calculate the file hash. Every file has a unique hash value based upon the content. Now, known malware file related code has a known hash. So, if you calculate the file hash, you can compare that hash with already existing file names and you can identify that is it a known malware file or not. So, antivirus engines use this method. Malware signature database. What is signature? File hash. Now, so antivirus companies collecting lot of samples. They are concluding that they are malware or not. They are adding the file hash into their signature database. Now, file A malware, file B not. Like that, they have a signature database. Now, if you calculate the file hash, if you check in a VirusTotal has a malware signature database related to the every antivirus in the world. It is easy for you to check which antivirus is detecting this file as a malware, which antivirus is not. Is it a known threat or unknown threat? You can figure out. Next, extract the strings. Okay, strings, it means words inside of that code. If you extract the strings from the code, if you observe those strings, you can find the hint. Maybe when you are extracting the strings, maybe that strings can contain the URL, strings can contain the IP address, strings can contain some function name, some file name, some IP addresses, some email addresses, some names. So you can find some interesting points. So you can link up the case. So you can find out that, okay, so strings, extract the strings, analyze the strings. Next, so identify the properties, headers. What are the files dependent? It can have as a dependency. It means that malware file is going to be take the support from the existing libraries and DLL libraries in your computer. We have a dynamic linking libraries, DLL, dynamic linking libraries. So those libraries, our Microsoft OS contain the DLLs. It means we are not asking our developers to build the functionality from the scratch. We are already publishing the APIs. Win API, Windows API. That API has a functions. Those functions are helpful to the developers to achieve their goals. Now they don't write the code from the scratch. They directly use the existing APIs. Okay, they want to create the service. They can create the service. They want to open the service center. They can open the service center. They can stop the service. Like that, different functions we have. Open SCA manager, create service A. Okay, so stop service A. Like that, functions we have. So Win API functions we have. Those functions are used by the developers whenever they design the executable file for Windows. Now, based upon the functions they are using, based upon the functions they are using, based upon the dependencies they are using, you can suspect that they have a malicious intention of that. So if you do the proper filing, properties, headers analysis, the dependencies analysis, you can figure out that. For doing those things, you are going to be use the tools. Malware analysis is a purely tool-based, logic-based. So you use the multiple tools for taking a decision. For example, if there is some case we have, some murder is happened. Now police suspect everyone. They will interrogate everyone. Based upon the information they will collect from the multiple sources, they will map with their evidences. They will come to the conclusion of that. It means a crime is not solved by a suspecting single person, am I right? Too many people we need to suspect, too many interactions, discussions, data collection, mapping that with our incident, then conclusion. So same way in a malware analysis also. You are not allowed to depend upon the single tool. You should use the multiple tools for the taking a decision, for the conclusion. Clear everyone? Then? Okay, so let me show you how to do that static analysis. How to identify the file type. So is it identify the file type and identify the program is packed or not? Okay, how can you do those things? You can do those things with the help of the simple tools like we have a PE Studio. It's all-in-one tool. So PE Studio is all-in-one tool, and you can use a DIE, Detect It Easy, all-in-one tool. Okay, CFF Explorer, limited features we have. Only if you want strings, you can use the strings from the sysinternals. Okay, so you can use a strings from the sysinternal. And if you want to calculate the hash and everything, you can directly do from their places. So those are a basic tools you can use. Okay, so we already have a tools. So let me extract the sysinternal suit because we need a strings from that. So we need a PE Studio, extract that. So we needed a dye, detect it easy. So all of you just please observe that. So it's just a task less than 10 to 15 minutes. I will show you on multiple samples. You guys can continue your practice. So practical malware analysis group, we have a so this book related labs we have, labs related solutions also we have. So if you go through this JMinter tutorials, he clearly explained like a one by one file lab related investigations. So in is a chapters so one by one you can find. So lab related, how to do the basic static techniques, static analysis techniques we have. So you can see that sample files how to identify that. So upload the files to the virus total and view the reports. Okay. So check is it a known or not. Okay. So those files are uploaded, verified how many antiviruses are detecting that. So when those files are compiled, it means malware development date. You can find that in a header analysis. Okay. You can find that in a header analysis. So is that file is like a packed or not? You can identify that with a PID software or detected EEG software. Okay, so type. You can check with them. Okay. So you can just identify that they have a packed or not. Verify that. What are the dependencies they have? What are the functions they are using? So now, so it is a copying file and doing those things. Find next file. So dependency walker you can use, or this dependency directly can find when you are using a detective easy. Okay. So you can say that what type of actions it is doing, creating process and all those things you can analyze. So it is able to do those many actions. So you need to observe that so is it has any strings contain any secret values. When you extract the strings, you can find some values. So you can observe that. So is there any indicators, infected network indicators? It means any IP address we have or not. Now see this, it is displaying the one IP address inside of that file. So when you extract the strings, that strings contain the IP address. So you have to is it as a purpose? Is there any backdoor purpose? So purpose of those files. Now if you observe that so those files has a so strings and everything. It has a Trojan backdoor access. It has. Okay. So if you observe that it is a one file is a packed one, UPX packed one. They are using a packer. You have to unpack that. So behavior. So you can look into this. Once you unpack, you can analyze that. You can find the extra activities of that. It is opening internet URL. Okay. So creating services, managing the service manager and everything. So just you don't need to go through all the chapters. This chapter one is enough to you to understand is it packed or not. Is it whatever we discussed, a static analysis part, you can finish in those labs. You have a lab file names and the questions. If you answer to those questions, it means you are good in a malware analysis. So how to achieve that? Okay, now question is that. So when was the program is compiled? That is a question. Now where you can find? You can find in a headers analysis. So you have to find the header and you have to report. So we have a lot of software. You can use a PE view software, PE detective software. So we have like a PE ID software, CFF Explorer, Detective TAG. All those are going to be helpful to you to do those things. So use any software, but find the information. Identify the information. Identify that there is any kind of URL, secret URL, malicious URLs, or malicious file names, and everything inside of that. So observe that is there any embedded mechanism they have. So they are like some look for the embedded executable file inside of the normal file. Now resource hacker can helpful to you to identify the executable file in a normal file. అర్థమవుతుందా? Okay. So we have a scenarios. So dynamic analysis require like a behavior analysis. So static analysis is simply like a dynamic analysis. You are going to be run the process and verify that. So what that process is exactly doing. Okay. So we analyze that, how it is like a created process and what it is doing. So I will explain about this like so dynamic analysis in the tomorrow class. Let's switch stick to the only chapter one. I will just share this link also in a group. Okay, after the class. So stick to the like a chapter one question and answers. Okay, fine. Now I extracted like a so die. I am opening the die. So we have like a die, like I said, this particular die tool. Okay, so you can just like a drag and drop which file you want to analyze, or you can drag and drop, like you can enable advanced options. So you have a permission to like so browse the folder. Okay, so you can scan the complete folder also. We have a directory. So let's scan the one file first. Now, so in this place, like so I'm trying to drag and drop this particular DLL file. Now you can see the like so details. It is analyzed. It is identified. This is the like a design in a language C++. So Visual Studio software they use to design this program. Okay, it's a Windows program, 32 bits program. You can see that. Now it's a PE file, portable executable file, 32-bit program. Okay, so you can see the like so all the details. Type is DLL file. So you have a details. Now, when you enable this advanced options, normally this is the basic view. But when you enable advanced option, you have an option to check directly strings. Also, you can do the analysis directly. If you click on the strings, it will extract the strings from that and it will display to you. Now you can see the strings. You can see the like a string create process, create mutex, create mutex. See this, it is loading kernel DLL file. So it is loading like a so DLL file. So DLL file. So you can see that there is an IP address inside of that. Now that is the attacker IP. Check that IP address reputation in a abuse IP. Who is database? If it is already reported as a malicious behavior. That's my point. So we have like a hint IP address. We have a hint. We have like a functions as a hint. So strings analysis we do that. Now you can collect the file hash. So we have a hash. You can collect the file hash. You can check this hash in a VirusTotal. to know that is it a known threat or unknown threat, or like a so it's not threat sometimes. So clean file. So you can figure out that. You don't need to copy this and paste because like it has a direct link to the VirusTotal also. I love to use a die because of the all-in-one features and open source, free.
Huh?
Now you can see that like a VirusTotal is reported. This one is already known. So you can see the like a DLL file and everything. Okay. So in a die we have options to like check. One more interesting thing is like a so entropy vote. This entropy can help us to identify that is it a packed or not. If you have a more entropy, there is a scope for the packaged program. Now it has a like a so very less entropy value, not packed. Got it? So we have a like even option to scan a group of files also. There is a directory option. You can scan like our entire directory or subdirectories. So you can just like scan all the files. Now I have like 5 files in that. Those 5 files related report. You can see this. Now lab 1 file, C++, simple file. Lab 101.exe file. It's a C++ file, simple file. So, but 2 file is a UPX packer they are using. See that? They are using a packer in that. They have a packer. So they have a, like a compressed sections like a so with a packer. Okay. Now so we have a like a lab 3 file. So it is like a normal language binary. Lab 4 file. You can see that like a normal C++ file. So you can discover that like a so group of files also you can discover. So you can just like analyze individual file. So now if you look into the lab2 file, what is the lab2 file problem we have? This file is packed, UPX packed. Now if you look into the like a entropy series, there is a entropy 7. More am I right? See, first two entropy is a very less because they started packaging. Middle of their package, they have a malware code. Got my point. That middle of the code has a more entropy. Packed evidence we have. So header don't have a package. See that header has a less, not packed, but not the header. Middle of the code has a package. So we have a like a, which package they are using? UPX package. So you can just like analyze that. You can just like we have a lot of options. You can just like use this one for the one by one. We can just like trigger. You can just like identify that UPX clearly. So you can check in a rules. Is it detectable or not? Yes, it is like a VirusTotal. You can rescan. So you can attach with a API token, or you can directly can manually visit the website. If you add that API key after registering in their website, directly you can rescan there, you can see the report. Now, so 57 antiviruses reported this one as a malware. Okay, so you can see that. Now, so we have a XFormat. Okay, so whenever any program start with the MZ symbols, MZ, it is executable file. MZ, executable file. So like a file type we can discover by looking into the first few bytes in hexadecimal format. So this is a disassembled code in an assembly programming language. So reverse engineers they can read this also, but you need a lot of experience on assembly language for understanding this. So file hashes, so strings inside of that file. So due to the a packer one, so you can't able to see the strings in a proper way. See this, it is a string is split so they are overriding one by one. So if you unpack only, you can see the exact things inside of this. So we have to unpack that. Now you can see the a DOS header. So you can see the a DOS header. So you can see the this particular program, executable program related. So we have a headers. So that header is displaying the date, which year it is published, 2011. This is a program compiled in 2011. You can see that. So compiled time date stamp. Okay. So you can see the so their sections. So they have 3 sections of the code within a packed format. So they have a multiple sections. Now in a sections, you can see the 3 sections. Sections wise, you can see the code. So those are files they are importing. DLL files. Those are files they are importing inside to that particular file. So those DLL files are ready. Guys are able to follow me. So how to unpack this? You found that it is a UPX utility. They are using a UPX packer. You need to use a UPX unpack method. You can find in a Google. You can download the software. You can unpack that. Okay. But UPX utility already we have inside of the CFF Explorer. That's why I'm recommending CFF Explorer to you. So if you use a CFF Explorer, so CFF Explorer has a CFF Explorer you can see that. So in a CFF Explorer, you can drag and drop that file and you can see that it is packed or not, and you can completely can see that. Now it's a portable executable file, UPX packed. Okay, so you can see the a modified date 2011. So last modified date, file hash and everything. So DOS header, you can see that headers. So 32-bit i386. So P32-bit. So multiple programs we have. So they have those are sections, 3 sections they have. So they are importing those DLL files, those DLL files are doing those actions. If you find the a virtual protect kind of function, it means so they have a pattern. Create service. Okay. So they have things, internet open, kind of. Guys are able to follow me. So we have a dependency walker. All those are dependencies. Now last we have one option, UPX. You can unpack. You have that option in a CFF Explorer. So you can unpack, you will get the original code, not UPX. Now this unpacked one, see that portable executable file. All functions properly they will work. Okay, so now they will display every activity they do. Previously you didn't get all of them. You are able to see everything. Every capability you can see. That my point. So limited capabilities you can see when it is in a packed format. So you can save this unpacked file also. So you can save, and I don't want to overwrite, I want to so save the file as another thing. So this is unpacked one, okay? So you can just do the unpacked one. So CFX Explorer die, and we have a sysinternal should has a strings. If you want separate strings, already die has a strings analysis. Okay, PE Studio also has a strings analysis. You don't need extra die strings for that. But if you want extract only strings manually, then you can use the strings from the sysinternal should. You can copy the sys strings program. So you can open the CMD. So you can call the strings once because it will ask for the permission installation. Now done. So strings, you can see the files. You can provide the file name, which file related strings you want to export. Now lab2.txt. We have a strings. Now I want a lab2 after unpackaged. Now you can see the unpacked file strings. So you can see the huge difference between those two different. This is a packed one. Packed one has a UPX keywords. URL is not properly coming. Words are not coming in a proper order. Did you observe that? Because it is a pack. You can't able to see every function they are using. So are able to see any service start and all those things? No. So we have a clear difference when you have an unpacked one. Same file, after unpacking, when you are investigating, see this, you have a clear words. You can see that clear files, file names, clear functions. What are the functions they are using? See, those many functions they are using. Those many functions they are using. Every function you can see in that code. You can see that a service name, mal service, some file name. So they are a URL you can see them. అర్థమవుతుందా? So you have a hint. So they are opening this. Clear everyone? Yeah? So you have to so detect, extract the strings, analyze those strings. Okay. So part of our a static analysis, we are identify the file type. We are identifying that program is packed or not. If it is packed, we are unpacking that for the analysis and calculate the hash value and check in a virus total. So and extract the strings, analyze the strings, and properties headers analysis. We already did that to figure out that. So if you use a tool name is called PE Studio, it is all-in-one tool. Malware analysis, initial assessment you can do with this. Okay. Now you can just drag and drop your files. So it is going to be start analyzing automatically. Check virus total score, identify the strings, identify the interesting keywords, imports and everything, and map the hash value and everything. It will give the so indicators. Is it a threat or not? Okay, so now we have indicators. So those are indicators giving hint that analysis. So creating service, virtual protection. So they have a UPX packer, self-modifying file. Okay, so we have a score. See the virus total score directly. All in one. Okay, so you can see the strings. But when it is a packed, it has a limitation. It can't able to do everything now. So it is creating a flag on those strings. Those functions are like red flags, malicious functions. Okay. But when you use this file, when you analyze unpacked one, you will get the more clarity. So now packed one has a limitation. Unpacked one, it is going to be analyzed easily and identify all the possible indicators also. Now see the like a proper strings, all with the red flags. Now those are malicious. Guys are able to follow me? So malware analysis I can do like this. Okay, let me show you like with a guy. I quickly like a scan with all my samples I downloaded from the internet. So let me like drag this one.exe file. So identify that what type of file it is. It is HTML file. What extension is .exe extension. But it is a file is HTML file. So don't trust the extension. Okay, let's scan this whole directory. How many files we have? Extension is one extension, but file type is different. Some files are packed, some files are not packed, some files are like a Linux supported, some files are Windows supported. So let's figure out that. So I hope that all of you got the idea how to do the static analysis. So you don't need to waste your time on like investigating on multiple files, but only do the chapter one. Analyze all those files properly, end to end. Figure out that, okay. I will share the like questions and answers also. Try to figure out that answer within your tools list. Now see this like a lot of files. It is a rare file. It is a like a Linux file. This file is UPX pattern. See that? One.exe file is HTML file. This is a exe file. This is a exe file. This is a rare file. So this is a like a C program. So this is a like a binary C program. So this is a like a packed one. Some section they have. Now this is like a C++ program. అర్థమైందా ఎట్లా అనలైజ్ చేసుకోవాలి? So let's work on this today. Let me know if you have any questions. Clear everyone? So in tomorrow class I will show you how to do the behavior analysis. It means how to run those programs and observe the behavior to declare they have a malicious behavior. Clear everyone? So who do this work in a real time? Do you think SOC analyst will do this? No. This is like a end-to-end malware analysis process performed by the malware analyst job role guys. Who has a malware analyst as a job role? Those guys do this work, the static analysis. Then your job is very simple as a SOC analyst. Check the file hash, check in a virus total. Only virus total is your paper. Got my point? This detailed analysis performed by the malware analyst who work for the antivirus companies. Got my point? So our students like us, so 70 plus students from our institute, they are hired by the LTI Mindtree for the malware analysis project. They are doing malware analysis for the Microsoft. Microsoft is the LTI Mindtree client. So now your antivirus engine is updated by them only. Whatever samples collected by the Microsoft engines, those samples are investigated by them, flag them as a clean file or malware file. That is pushed to the entire world. Okay? Fine. So those guys also follow the same steps. I just like a train on them on the same process. They are using that. Fine. So let's work on this static analysis today and let me know if you need any. Okay, fine. Thank you all.